Well, first, thank you so much for having me do this here. The Restoration Authority was instrumental in us getting to this point. And so I'm going to give a brief overview of the project, some of the technical things that we've done, and an update on what's occurred this past year. So we launched this project in around 1990 when we saw the opportunity to beneficially reuse sediments from the dredging projects around the Bay Area, and perhaps through this provide a streamlined path for getting dredging done and accelerate restoration of wetlands around the Bay. We selected our site, which is at the junction of the fresh and salt water, fresh water coming down from the Sacramento River and the salt water from the Bay. It's called the Null Zone, and it's historically been viewed by biologists as one of the key areas for the nursing areas for young fish, and may provide, we hope will provide a key to helping restore fish populations. The site, because we're on the deep water old port of Collinsville, we're able to bring barges right to the site, and it provides a very efficient alternative to ocean disposal. And we've received 9 million cubic yards of sediment to date. We're able to operate 24/7, 365 days of the year, which we thought was important in order for the federal agencies and the Corps in particular not to dismiss us as a bother. Here's an infrared photo of the Suisun Marsh. Steve Chappelle knows this pretty well. As you see there, the Sacramento, our site is outlined, the wetland portion of our site is outlined in yellow. We own about twice that amount of land, including farmland and transition zone habitat. You can see there that the Sacramento River makes a sweeping left-hand turn, which due to centrifugal forces scours out the right bank and provides eternally deep water at our site. So we've got 22 feet of water at low tide. You can also see, based on the infrared imaging, that there was very little life on our site before it was restored. So even though it was jurisdictional wetlands, it was a prime opportunity for restoration. Here's a map of the site drawn in 1866 by a couple of drunk surveyors, I believe. And you can see that the area we're restoring was once tidal wetlands habitat. And as you all know from your important work, working with nature is way easier and more sustainable than trying to work against what nature intended. Here is an air photo, Google Earth image actually of our site. And you can see at the bottom of our site, 2 ponds. Those ponds can hold 64 million gallons of water. We have water rights on our site, and so we're able to fill those ponds. And when we're not taking water to slurry sediment from the river, we're allowed to take water August through December. We can fill those ponds, and we can slurry the sediment from there into the phase 1 area, which is the white area you see up in the middle of that picture. Here's a diagram that shows why we're able to safely take non-cover sediment, which is sediment classified having slightly higher concentrations of either heavy metals or organics. And the reason is because below the upper 6 inches of a wetland surface, where you see here as the aerobic soil layer, there's an anaerobic soil layer. And under anaerobic conditions, the cationic heavy metals like cadmium, lead, copper, zinc, so forth, form insoluble salts. That's basically freshman chemistry at Berkeley, maybe senior chemistry at Stanford. But as a result of that, and the fact that many organic chemicals that might be present, like DDT or low concentrations of polynuclear aromatics, which you find in asphalt and things like that, they bond through high partition coefficients to those soils as well. So in a non-erosive environment, you can capture and sequester those chemicals forever. This year, we were able to, some of you might know from our permits, we created and preserved vernal pool habitat on the site, and this year enacted a conservation easement to permanently protect that area. We completed a whole host of regulatory approvals, and Laura Cholodenko knows what these are because she reviewed them all in extraordinary detail to give us the authorization to proceed. This year, we also completed an overhaul of the entire Liberty offloading system. The project, in addition to the environmental benefits, it supports good paying union jobs. We've got a partnership with operating engineers. We just had a huge event. We breached the phase 1 area. David Lewis was there, he saw it, and it was just wonderful to see. It went flawlessly. I'll show you a video of that in a minute. We have had very good success with lease turn colonization. Lease turns were not expected on the site, but they seem to like our site, and they flew in, and they've been nesting at our site for many, many years. And I think we've established some new public-private partnership models that I think could help other restoration projects as well as other kind of projects around the bay. This is a photograph of one of our cells. Before we breached, we took 15,000 cubic yards of sand from Georgia Pacific, and then once we put it in the ponds, we excavated it out and used it for the area for the lease turns. Here's a couple of lease turn chicks. We had a good year this year for survival. We overhauled the whole Liberty offloader in Rio Vista this year. The Liberty fits into our offloading system, is basically the heart and the aorta of our offloading system to offload sediments. We can offload a sediment barge of 4,000 yards. We can offload that in about an hour and 15 minutes if it's mud. We rebuilt motors and purchased new ones in Houston. That's the best place to do this kind of stuff, and refit them on the Liberty. We installed vibration and motion sensors to give us 24/7 monitoring capability to minimize the chance of failure during an offloading event, which we have had, by the way. We took out and serviced the fish screens. You can see these two fish screens. They're 1/16 of an inch slots, stainless steel. They were perfect after decades of service. It's very interesting. But the support system in the back, which you can see, which was not stainless steel, which was just steel, corroded, and we replaced and rebuilt that. It's all been reinstalled, and the Liberty made it back to our site after 5 months. The phase 1 restoration work, we've been filling the site since 2003, and we confirmed through LiDAR surveys that we were able to reach the post-filling elevations. We 2 years ago won the first Measure AA grant from the Restoration Authority. Thank you very much again, to help us return this first 550 acres to the tides. We've also collaborated with the resource agencies on joining a regional wetland monitoring program so that data from all around Sioux Marsh and elsewhere can be combined and taken on with similar metrics and combined for a larger picture of what's really going on in the estuary. Here was our plan that we came up with 20 years ago for what phase 1 would look like when we restored it. And I circled in red the phase 1 breach that we had been planning. And you can see we kind of try to reconstruct this dendritic pattern of channels. The way we actually did it is we constructed our ponds where we contain the sediment in the outline of those channels. So we only had to make the levees one time to isolate the sediments and contain the sediments, and then what's in between those ponds are the future channels, and you can kind of see the pattern. So then on October 27th at 8 a.m., we breached the site, and we used 2 long reach excavators. We could have done it with one, but we just don't take chances with anything, and this made it, in my mind, 100% certainty it would go well. And that is literally, I don't know, 15 minutes, 5 minutes or so after the breach started happening, and it started filling up all our channels. Later that day, it had filled up all the low areas. When we did that at low tide, by high tide, it filled up some of the low marsh, all the low marsh cells, and the birds started coming in. And then And then later that afternoon, if you see in the distance, a herd of elk moved in. I think Steve Chappelle moved them there, but they somehow figured out that this was the place to be. So what took us like 20 years or more, 30 years really, when you consider it, to plan and execute, the wildlife figured it out in a matter of hours, and it has been just flush with wildlife since. Some of the work that you guys paid for, we did all kinds of transplanting and levee work to prepare this. Here's what the breach looked like a few days before we breached, and you can see we dug out that channel area to the right depths. We did all kinds of modeling to figure out what those depths are. It's complicated. And then you can see, where that Montezuma levee is. For scale, we dug out the center of this to give it the hydraulic capacity that we thought it needed. It is essentially the aorta of the system. All the water for phase one comes through there. And for scale, you can see the two workers in the center of the picture. We installed a monitoring pile about 200 yards up from the breach. And on that pile, we've got an electroconductivity salinity sensor. We've got a water level depth radar probe, and we've got a 24/7 pan tilt zoom camera. So we have photographs, live photographs from the marsh 24/7. Here is a salinity plot that we got from the first few days after it. And what we first saw in this was really two things. The salinities in Montezuma Slough pre and post breach were about the same. So we didn't affect anything badly, and all the salinity modeling we did over the years suggested that would be the case. But you can also see a dip in salinity, and this is electroconductivity, which is about, salinity is about 60% of this. But you can see that at like 10 a.m. every morning, salinity goes way down, and we then learned that there's a duck club across the way that pumps water out at 10 a.m. every day. So it's very interesting, the kind of data and things you can learn about how systems operate if you actually collect data. And so we're big on data. I'm a cow guy, so so we're going to have a lot of it, and I just really look forward to the future. So what does the future hold? We think our site's going to be a very important role in the recovery of endangered fish species. In the analyses that the Corps did, we scored the highest potential reuse site in the region for ecological benefits. We've got about 13 million yards and 20 more years of operating life. And at the same time, we only use the offloader, a third of the time. And so it is available to use on some of the other sites that you guys are considering. It's not a walk in the park to either own or maintain one of those things, the offloading system. And I showed you some pictures of it. I think this year we spent 1.2 million on maintenance, some of it for which we had a budget of about 700,000. So we just paid for it, but you don't always know what's going to happen when they get in there. And that's hard for a government agency to handle because you guys have to do budgeting ahead of time. How did we get here? And I just was asked to reflect on this for another presentation I recently did. I've identified 5 major ingredients that made the San Francisco Bay region one of the 3 regions that lead the United States in beneficial reuse. We had environmental advocates pressing for a new sediment policy. And without the environmental groups, we would not do anything. I mean, the system doesn't respond on itself. We also had in the 90s, we had visionary congressional and Port of Oakland leadership. And as you recall at the time, Congressman Ron Dellums was the chairman of the Armed Services Committee. And his people, Lee Halterman in particular, and some of you may remember Lee, put the deal together to put us, Sonoma Baylands, and Hamilton in the congressional authorization for the Port of Oakland 50-foot project. So that was very key. Industry, Bay Planning, and Bay Area Council supported this, and the dredging industry was willing to adapt. Not all industries are willing to adapt to new rules. And that's obviously what we see in some of the other challenges we're facing with global warming and the petroleum industry. There was really collective wisdom and hard work of county, regional, state, and federal agencies, including the Coastal Conservancy and the Restoration Authority. When we first proposed this, it was a novel idea. It seems so standard now, but trust me, it did not feel that way at the time. And we had to prove everything 3 times over. And the county and all these agencies really worked hard. We're impartial, we're objective. They double checked everything, and it resulted in the permits that we have. And of course, we have an innovative, highly competent, and very persistent project team. And I'm listing them here. These are folks, some of them you may know. Peter Hornick was the only equity fund that was even interested in talking to us. They helped finance our project. Doug Lipton, I think you guys know, our chief scientific officer. Roger Leventhal, who I think you know, and myself, we're chief engineers. Cassie Pinnell, who you may work with on other projects from Volmar. She's now been promoted to our deputy general manager for the Montezuma Wetlands. So if I get hit by a bus, Cassie will be the one to take over. Sharon Hall, the TRT, the technical review team, which is a group of scientists and regulatory agency representatives led by Josh Collins of the San Francisco Estuary Institute. And they have been amazing. We've had to do a lot of adaptive management. And what we do is we come up with ideas and they help us analyze those ideas before we put them into practice and before we put them into permit modifications, which we have done. Past staff, Rachel Bonifil and Stu Siegel have worked on this. And then I'll just say the Port of Oakland, without these following people, this project would never have been possible. The Port of Oakland was absolutely visionary. Bill Bagley, a Bay Area icon, a very moderate, incredible former Republican assemblyman who took us to Washington, D.C. and made it happen there. The Bay Area dredging contractors, the Ferrari brothers who own Firma, where when I did not have any financing, they financed the project to get me ready for phase one. And then, of course, Mark Reisner, who passed away, the renowned author and visionary author of Cadillac Desert and other books. Mark was really the first environmentalist to endorse the project, and I just love him, and I'm just so sorry he's gone. Anyway, that's my presentation. Thank you very much. If you have any questions, I'll be happy to answer them.